Let's look at a couple more polar graphs. I have a table here and it's already filled in. I'm going to try my best to show you the TI-36 and help you see how you can do this. So I've got just my calculator. I'm going to press table and you see that it says enter or edit function. So I go down there and I hit enter. I've typed in 3 times the sign of 2x and then I'm going to hit enter. I have it set where it's asking me each time what my x value is, so that's helpful to do. And I just keep hitting enter until I get to the table and I type in my x value, which is my theta, and it gives me back my r value. All right, so just a little calculator reminder. We have all these points. It's time to graph. Let's see what this thing looks like. So 0, 0 is our first point. It won't always be the pole, but it is in this case. Pi over 6, we're stepping out 2.6, 1, 2.6. Pi over 4, we're stepping out 3, 1, 2, 3. Pi over 3, 2.6, and then back to the pole. So we need to remember the order that we're doing these things in. Then 2 pi over 3, we have negative 2 pi over 6. We're going to go in the opposite direction. That's toward 5 pi over 3. 1, 2.6. Pi over 2, 0. Wait, 3 pi over 4. Sorry, 3 pi over 4, negative 3. So instead of going toward 3 pi over 4, we're going the opposite direction. 1, 2, 3, towards 7 pi over 4. 5 pi over 6, but instead of going towards 5 pi over 6, we'll go the opposite direction, which is 11 pi over 6, 1, 2.6, and then back to 0. So we need to be remembering the order of events that are taking place here. I love these. All right, 7 pi over 6, we are stepping out 2.6, 1, 2.6. 5 pi over 4, we're stepping out 3. 4 pi over 3, 2.6, 3 pi over 2, back to the pole. And then 5 pi over 3, negative 2.6, that sends us the opposite direction towards 2 pi over 3, 1, 2.6. Towards 7 pi over 4, nope, it's negative, opposite direction, 3 pi over 4. And then 11 pi over 6, nope, opposite direction, 5 pi over 6, which is 2.6 out from the pole, and then back to 0. All right, so let's remember we started here, we went out to here and then to here and came back, then we came out this way and came back, came out to the quadrant 3 information, came out to the quadrant 2 information. We have graphed a flower. In fact, these flower shapes are called roses. Now, if you know anything about flowers, it doesn't honestly look much like a rose, but that's what they're called. So this shape is a rose. All right, and in fact, let me write that down. The next one we're going to look at is r equals 2. We saw theta equals some number in another video, so let's talk about what happens when r is equal to just some number. Well, so I've just listed out a lot of 2's here. Since theta isn't mentioned, it means theta can be anything. So I've listed a variety of thetas. You could just pick any ones you want to. So I go towards 0, the angle 0, and I step out 2. Go towards the angle pi over 6 and step out 2. I almost did pi over 4, might as well. 2. Pi over 2, I'll step out 2. 3 pi over 4, I'll step out 2. Pi, I'll step out 2. I'm beginning to see a pattern form here. It doesn't matter what angle I choose. Doesn't even have to be, one of our unit circle values. What's happening is I'm looking at a radius of 2 away from the pole, and theta can be anything. So in fact, it is everything. What we have here is a circle with radius 2.